Hey guys, what's up? Today we're looking at finding the function f using antiderivatives given f prime, or in this case possibly f double prime. So what we want to do is we want to take f prime, we want to antidifferentiate it, we want to get f from that. So let's look at our first example here, part A. It says f prime is x plus 1 over square root of x, and then the condition is f of 1 equals 5. So what we can do for part A is we can say, rewrite f prime as x over square root of x plus 1 over square root of x. So just do a little algebraic manipulation first. So that's x to the 1 over x to the 1/2 plus x to the negative 1/2 if I just rewrite this in terms of powers. So this is going to be x to the 1/2 plus x to the negative 1/2. So that's really what f prime is. So now I antidifferentiate each piece using the power law. What's the power law? It says x to the n, antiderivative of x to the n dx is equal to x to the n plus 1 over n plus 1 plus c. So the antiderivative here, f of x, is going to equal 1 over 1 plus 1/2 x to the 1 plus 1/2 plus 1 over 1 plus negative 1/2 x to the 1 plus negative 1/2 plus c. Now do some simplifications. This is going to be 1 over 3/2 x to the 3/2 plus 1 over 1/2 x to the 1/2 plus c. And this can simplify to f of x now is equal to 2/3 x to the 3/2 plus 2x to the 1/2 plus c. Now we use our initial condition, or our condition f of 1 equals 5. So f of 1 would be 2/3 1 to the 3/2 plus 2 1 to the 1/2 plus c. And now that should be equal to 5. So 2/3 plus 2 plus c should be 5, which would tell me that c would be equal to 5 minus 2 minus 2/3. So that turns out to be 7/3. So c is 7/3. Take that and plug it back into f, and we get f of x is equal to 2/3 x to the 3/2 plus 2 x to the 1/2 plus 7/3. And that is our solution for part A. This is the function that satisfies the derivative condition and f of 1 equals 5. All right, so let's look at part B. All right, so for part B, the first thing we want to do is again simplify a little bit. F prime of t can be rewritten as secant squared t plus secant t tangent t. Now the antiderivative, f of t, we ask ourselves, what function do we differentiate to get secant squared? Well, we must have differentiated tangent, because derivative of tangent would be secant squared. And then what function do we differentiate to get secant tangent? Well, we differentiated secant. And then plus c. Now we use our condition, f of pi over 4 equals -1. So f of pi over 4 equals tangent of pi over 4 plus secant of pi over 4 plus c equals negative 1. So this tangent of pi over 4 is 1, secant of pi over 4 is square root of 2, plus c equals negative 1. So that would tell us that c would be, subtract a 1 and then subtract square root of 2. So negative 2 minus square root of 2. So that tells us our function f of t can be written as secant, or tangent t plus secant t minus 2 minus square root of 2. And that's our solution for part B. Let's look at part C. So for part C, there are a few things we need to remember. The first thing we need to remember is the antiderivative of b to the t dt is equal to b to the t over natural log of b. So that's going to be important. So the first one, f prime of t equals 3 to the t minus 3 over t. Now, anti-differentiate both of those. This 3 to the t is of this form, b to the t. Stick a plus c there. So this 3 to the t is going to anti-differentiate to 3 to the t over natural log of 3 minus, and then 1 over t, that's 3 natural log absolute value of t. So that's another one we need to remember, is that 1 over t anti-differentiates to natural log of absolute value t plus c. All right, and then just combine those two constants, we'll get one constant plus c. All right, so now I've got a condition here, f of 1 equals 2. So f of 1 equals 3 to the 1 over natural log of 3 minus 3 natural log of 1 plus c. But natural log of 1 is 0, so this term is 0. And this is supposed to be equal to 2. So then c is equal to 2 minus 3 over natural log of 3. So that tells us f of t will be equal to 3 to the t over natural log of 3 minus 3 natural log of t, absolute value t, plus 2 minus 3 over natural log of 3. And that's our solution for part C. And lastly, we'll look at part D. So for part D, we actually have a second derivative, f double prime. So what we need to do first is find f prime of theta. So anti-differentiate one time, we get antiderivative of sine would be negative cosine of theta, plus antiderivative of cosine would be sine of theta, plus, we'll call it C1. All right, so we can use our condition on f prime to say f prime of 0 is equal to negative cosine of 0 plus sine of 0 plus C1 should be equal to 4. So cosine of 0 is 1, sine of 0 is 0. So this is 0. This is 1, so it's actually negative 1 because there's a negative out front. So this becomes negative 1 plus C1 equals 4. So C1 equals 5. So C1 is 5, and now f prime of theta can be written as negative cosine of theta plus sine theta plus 5. Now we antidifferentiate again to get f of theta. So antiderivative of negative cosine would be negative sine, because if I were to differentiate negative sine, I would get negative cosine. And then antiderivative of sine is negative cosine, so I put a negative cosine theta plus 5 theta plus c2. So call it a different constant. And now we use our first condition, f of 0 equals 3, to find c2. So f of 0 equals negative sine of 0 minus cosine of 0 plus 5 times 0 plus c2 should be equal to 3. So that tells us that c2, let's see, this is going to be 0. This is going to be negative 1. 5 times 0 is 0. Negative 1 plus c2 equals 3. So negative 1 plus c2 equals 3. So c2 equals 4. So that tells me f of theta is going to be negative sine theta minus cosine of theta plus 5 theta plus 4 is f of theta. And that is our solution for part D. And we can check. Plug in 0. We get 0, negative 1, 0, 4. So negative 1 plus 4 is 3. That satisfies my condition. Differentiate it. Plug in 0 satisfies my condition. Differentiate twice. We should get this function here, f double prime. And that's how we find antiderivatives. That's how we find the function if we have conditions and we know the derivatives.